Alright, this is a short stream, and I'm realizing I'm cutting things a little close here by testing my cameras as I'm getting started instead of right before I get started, but sometimes that's how I roll. Anyway, hi, I'm getting back to a thing here. So, this stream, as I like to do a little introduction at the beginning for folks surfing through the archives, this will be a bit of a short stream on some of the progress on the Tuco Flyer. Specifically, I wanted to look at a bug tracker. I just started setting up the GitHub issues with, you know, some stuff to work on. This is actually the view from the Flyer right now, behind in the sky, nice and stable. And then here's the desk. So yeah, I thought we'd have a pretty short stream, take a look at a couple of things I got in the mail and the bug tracker, and then, assuming we don't run out of time too quickly, I'd like to maybe try looking at the LED problem, which is now an actual bug. It is now issue, oh geez, it's scrolled off the bottom of the screen. Yeah, it is issue number 10 in the bug tracker. So that is a thing we can try to work on. I'm also working on issue 17, the leash is too heavy. This one is actually what's preventing us from really navigating that smoothly in the rear side of the room where it's furthest from the leash attachment point. And that's really just because the leash is kind of pulling too much on the robot. There are a few ways to fix it, including adding additional kind of dummy weights to some of the control lines, decreasing the lower limit on the forces allowed on the winch, or just making the leash lighter. And so I figure we'll probably want a combination of strategies, but I know at the very least it's worth making the leash lighter because the first incarnation of it was not weight optimized at all. So I'll just switch to using, you know, higher voltage, thinner wire, basically. And, oh yeah, the shirt. Yeah, where did I got this, there's like a road trip in the desert, around somewhere in New Mexico. I got this shirt. That was a weird road trip, but yeah. It was pretty warm at the time. So yeah, I ordered the parts for this. I figured we'd try this stuff made by Monoprice. It's actually 28 gauge Cat 6 cable. And then because I'm only running 100 base T over this, I only need 2 of the twisted pairs. And so because of that, oh, see, that time you got to see my monitor flash. Usually I'm the only one who has to deal with that. And so we could use the other 2 28 gauge pairs to carry our power. And like, admittedly 28 gauge is pretty thin for power, but I think it'll do. Right now it is drawing about an amp at 12 volts. And I figure I'll boost it up to 24 volts instead and have a DC-DC on the Flyer that goes back down to 12. Right now there's a bunch of DC-DCs that go from 12 down to 5 for the different 5-volt subsystems, but the gimbal can't handle 24 volts directly. I think it's rated to go up to 17 volts, and I don't know if I'd want to run it that high on its range. Sorry, gotta keep the tea flowing, otherwise I run out of moisture. So yeah, let's do a little quick demo of this. So can I actually get the debug view on the screen too? Yeah, okay. That doesn't look like it's very different at the moment, but and then I switch this view, turn on the controller. So there are a few things that are actually pretty nice now. I can put the robot in halt mode, which is where it's at right now, and it actually gives me a pretty stable camera with a pretty unobtrusive overlay. So there's a very faint red border around the screen right there, which indicates the robot is trying not to move. So it's actually still commanding the gimbal to try to hold the gimbal in the current position, but it's not going to tell the gimbal to move anywhere else. It's acting like kind of there's a very weak spring return kind of pushing the gimbal back to the last position it was stable at. Sort of how it works. It's like a drift compensation algorithm is the way it's described in the code. So that's still active, but we're not actually trying to track anything. It's stationary. And so because we're not tracking, I've turned off the little cat sprites. But if I put it back into manual Flyer mode, now the tracking's on. Where's Tuco? Oh, there he is. Tuco's drinking some water. So I think we could actually spin over here. And if we get close enough, oh, he's over on the carpet. And so we might actually have to move the camera down. So anyway, so far I haven't moved the camera, I've just been moving the gimbal. But I can move the camera too. And as you can see, it's a little wobbly. There are a couple of reasons for that, which we can go into. I'm gonna lower it. But yeah, so like the state it's at right now, there are a handful of bugs that make it less presentable than I'd like. Kind of the two biggest ones that I'm hoping to fix before I do the next edited video on this is I'd really like, so we'll see the other problem in a sec. It's not really visible from your current vantage point, but yeah, like right now I can move it pretty smoothly and it does a decent job at ramping up and then maintaining fast motion. But then as I slow it down, you know, so I would expect that to be the difficult thing to, you know, the difficult period of the motion to avoid wobble anyway, because that's where you've got to kind of dissipate a bunch of energy without it turning into oscillation. So I expect that to be challenging anyway, but right now it's just extra bad because the, you know, and getting deeper in the rabbit hole here, but then it's because during the motion, it was not doing a good job of estimating how much it actually needed to pull in each of the chords. So it's going to end up, after the main motion finishes, still having to kind of settle the tension out so that none of the winches are outside of their tension range. So that involves a lot of this tension adjustment control loop oscillation, which is something else that I need to tune out. So it's one of those things where there are, I think, several related root causes that all need some attention on their own to debug. And there are certainly some like physical heavy hammers that you could use, like, oh, just put everything under tons of tension, or just put tons of weight on it, just add a huge counterweight, like whatever. But like I agree that maybe some of those could help, but that also has the consequence of making the robot more power hungry, less safe, heavier, and so I would like to try to solve as much of the problem as possible with, you know, making the control loop run smoothly rather than kind of trying to brute force the mechanism. And then if we do want to make mechanical improvements, then like the control loop improvements will only be better, you know, in combination with those, right? So I think that's the plan at this point. Let's see, I think this is maybe a good time to jump into opening some mail. I got a couple things in the mail in the last couple days that I thought we'd take a look at. Let's get a card in the camera. I actually don't have a viewfinder on the camera because it disables that when I plug in the HDMI, so I actually have to switch this to the viewfinder to even format the card. Vince says the motors and gearing make a pleasing sound. Yeah, they have pleasing elements. I'm not totally sold on the way it sounds right now. A lot of that is just related to its motion behavior, though, because as it ramps up, I think it sounds pretty good at the moment, but then it does a lot of oscillation as it tries to come to a stop, and that can sound annoying. So I think it's really just that right now the sounds are doing a much better job of tracking the actual motion because of the different PWM strategies it's employing for fast and slow motion now. Hey there, Train. Oh, and so as usual, we're streaming on YouTube and on Twitch. I think most people still prefer to watch on YouTube, but it's always good to have the backup for those times when YouTube kind of breaks on your particular ISP. And so just as a reminder, we have that on twitch.tv/scanlime. I also sometimes run a separate stream that's just the flyer robot. In fact, we might as well turn that one on too, because it's always fun to have going. And that's twitch.tv/TucoFlyer. And so, yeah, I'll get that one started up. So if you just want a full screen view of what we see on the debug view of the robot, you could actually just go to that. Oh, Vince's already been having trouble with YouTube. Well, that's why we have backup systems, folks. Yeah, it is nice to have options, but yeah, YouTube works nicely sometimes. This is another little tidbit, which I don't know if we will get to this at the rate I'm going. I don't know if we'll actually have time, but this is what we might end up using to fix the LEDs. We cobbled this together on a previous stream. This was just a convenient source of a breakout board for this 74HCT245 chip, which I'm using as a 3.3 volt to 5 volt level shifting buffer. And so in this case, I wired some of the inputs to this to this buffer up to pins that would normally go to the debug interface, and then the debug interface comes out here, so you can sort of use this as a crude level shifter, which we might end up getting to. More hacks for prototypes where we didn't print a custom PCB for the whole project, right? Anyway, let's start with this one here. Let's do a quick opening of this. Do I not have a real tool? I guess I could open it with one of these. E-packet. So some people might recognize the shape of this box. Yeah, so we had a problem with the winch motors, in specific winch number 3, so the one in that corner, just totally busted a gear. And then we opened it up, and, well, there were a number of reasons why it might have failed, but I think a lot of the problem was actually just shoddy manufacturing in the original, and it came down to the way that they chose to secure one of the gears in this gearbox to the metal shaft using this pin, which was kind of haphazardly inserted to the point where it weakened the plastic and then like melted over on the edge, and so that wasn't good at all. So I ordered so first we tried to 3D print a replacement gear, which worked for like a few hours and then broke. And then I got another motor in the mail, which was not from the same source, but I think was basically the same motor, just sold by a different manufacturer under a different part number. And that one was a little bit more expensive, but I could get fast shipping on it. So that one turned out to fix the problem, basically, and it seemed to be better manufactured to begin with. Like, it didn't have quite such a shoddy-looking gear inside. So, finally, after a trip from China Post, we have the exact same motor that I originally got. It actually seems to be maybe slightly newer because this label looks a little bit different, but the one that's actually in the winch has that printing on this side, and the label is formatted a little differently, but it's the same part number. Anyway, this is the same motor, at least it should be. It might just be a slightly newer vintage, but I wanted to really quickly look inside this to see if it has that same gear problem. So I'm going to grab a rubber glove. Oh man, I was tidying stuff up today and I might have put the glove somewhere, I don't remember. Alright, auxiliary glove stash. I think I have a spare box elsewhere. I mean, I could get shmoo all over my hands, but I could also not, which seems fun. Oh, the camera. Still on Tuco. Good job, camera. This would be a good time for me to find the original box of gloves, right? Oh. Okay, this is much too large of a screwdriver. And sorry I'm a little behind on chat. I'll catch up in just a sec. Oh, someday I'll figure out how to organize screwdrivers. You know, I feel like I've been so much more organized with my hex wrenches since I got that one nice Wera hex key set. Which isn't to say that the solution to organization is to buy new tools, but if I could at least find, like, cull my set of screwdrivers down to the ones I actually like, that might actually help my shop be more organized. And I probably would find some gaps in my set and end up wanting to get some more. Oh, geez. Oh, okay. That's pretty tight, but I can get that out, kind of. Was there any Loctite on there? No, just torque. Just kind of torquey. Screwdrivers go in the bin. Yeah, that's kind of my problem right now. I don't have like a nice wall rack mount kind of thing. I just have like a messy bin. Oh, Len recommends I should get some massless cable. Isn't that wireless these days? I mean, we could do wireless power. We could, I mean, you know, I've been thinking about how hard it would be to adapt this strategy to something where the cable goes along each individual nylon cord. It doesn't even have to be that, you know, we don't have to like go to slip rings or whatever. We could even just have something kind of like the current sort of folding cable clamp situation, but running along each of the individual cords instead of to a separate leash anchor, and that might be nice. Urgh. This one's kicking my butt right now. I'm gonna get another tool. Maybe a little vice grip. Shoddy Manufacturing buys another, right? Well, so I bought another one from a different manufacturer, hoping that would work. I bought another from this manufacturer because I needed a backup plan. I didn't know if the other one would work, and so, like, it's not that I liked this manufacturer. It's that I wasn't sure if the other motors would be exactly the same until I got them. So, yeah, like, I agree that these folks don't deserve a ton of additional business if all their motors are that bad, but part of why we're opening this is to see if they are bad, or if we just got one that was particularly bad. You know, whether they just generally make bad motors, or if they just had a quality control issue there. So, same inside so far. How many of these have we opened anyway? And let's put down a science paper towel. I don't think Servo AF can handle this particular job. Okay, I think this was easier when I took this output shaft out first. Maybe I'm lying. Maybe I can just take this out straight away. Yeah. All right. What's the verdict? Ooh. What the hell? Yeah, I'm not buying from these guys anymore. This is nasty. Oh. And so that other manufacturer that was selling a very similar looking motor with faster shipping for like $10 more, they did not have this problem. It might be worth getting this under the microscope because I don't think I can zoom in quite a bunch more on this camera. And this might even be easier to do with the gloves on. She says, while trying to figure out how to adjust the microscope height one-handed. Alice says, it came so blurry from the manufacturer. I know, right? How can you tell what's going on when the gear is so blurry? Okay, so I know there's a bunch of shmoo going on there, but I'm pretty sure that's already evidence of the same, like, terrible melty pin hack job that the manufacturer put in the previous gear. So I think I'm going to expect winches 0, 1, and 2 to all break in the same way at some point. And maybe winch 3 will last a little longer since I don't think it has the same problem. But yeah, I don't want to spend a ton of time going into this, but maybe I will scrape off a little bit of this so you can get a better view of what the actual problem is. Ugh. Man, now I'm just trying to imagine what conditions caused them to reach the conclusion that this was how they were going to assemble this gearbox. That is just so weird. It doesn't look like a clean hole like you would expect if that was, excuse me, they're drilled after the fact or is molded into the original gear. Like, that looks very much like a hot, pokey tool, like a soldering iron or something, was just stuck in there after it was assembled. So yeah, I don't think this is good. I think this is not how you want your gearbox to look. I'm gonna put like a unhappy, sad face on this gearbox with Sharpie and use it for something non-critical and not buy these ever again. All right, well let's put this back together quickly. It is good to know that I can get basically the same motor from other suppliers though, and that they're not all quite as bad. Although I really won't have any way to tell if they're good without buying one, probably. Now, these aren't cheap motors. This was like a $50 motor. I mean, really, the problem is that I just can't really rely on this style of motor. I think I need to separate the gearbox and the next version of the winch. And I have to talk about that like as if there will be a next version, because that's how you have these kinds of engineering discussions. But like the next version of the winch, like that would probably be based on 2 motors, maybe one fairly low-end gear motor, possibly like this, because you wouldn't really rely on it for much, and that would just run the spool, and then probably something a bit more custom with a brushless motor and like a belt or gear drive to actually take up the cord through a capstan. And I think that would be better. You'd end up with just like higher quality parts on all the really critical areas. Because yeah, just like looking for a motor with the kind of specs I needed, you end up with a bunch of stuff like this, which just isn't great. I think these are usually used for power windows in vehicles, so they're usually not under that much stress. But then, they're also something that'll break a lot, and someone will just replace them anyway. So, whatever. Alright. At least this one was packed better. The last batch of motors I got from them, one of the motors had shipping damage, and that's why I opened it up in the first place, because it seemed like the shaft was slightly bent. Oh, toques on the rack. That's... Oh man, I'm so bad at coordinate systems when I drive this sometimes. Okay. This is why normal mode in the controller really needs to be in camera coordinates and not in world coordinates. Right now I'm flying it in manual flyer mode, which is world coordinates, and it's tricky from where I'm standing. Yeah, just looking at the chat, Ryan's wondering what that grease is. I don't know specifically. It looked like it might have been like moly grease or something, but I don't know specifically. I'm not a grease expert. Aiden's wondering why it wasn't a Metal Gear. I thought maybe they didn't have a metal gear, maybe it was nylon to reduce noise. My theory is that it was a plastic gear because it would have been expensive to machine a helical gear out of metal, and so they used a plastic gear because that one had to be helical to mesh with the worm gear. That's my theory. I'd be interested to know if anybody else has theories about that. Okay, yeah, Ryan says it looked kind of like Molly, but Molly would be expensive, so, well, maybe this is why, maybe it was just expensive and shoddily made, who knows. Like I said, these weren't super cheap motors. Okay, I've got one more package here. So, this is a hardware donation from Axel Thielman. And let's see. This box is already slightly starting to open itself. Oh, sorry, this is not hardware, this is a book. That's right. That's right. This is a rare book that they found at a local library that was cleaning up shop and thought about me. Ah, yes. Oh, the Multics system. Oh, that's great, from the MIT Press. Ah, man, yes, I'm an operating systems aficionado, so I appreciate this. I've never really dug into Multics at all, but, oh yeah, from Hamburg. Pink big bubble wrap, yeah. Oh man, the GE645 paging hardware. Oh man, all sorts of linked lists. I wonder if this had cache. Let's get a slightly better view on this. Oops. Yeah, this is great. The Multics system, an examination of its structure. So we're talking about memory segmentation, basically just going through the really basics of what you would need to start using a computer for multiple users. You know, privilege levels and memory segmentation. Execute only segments. Memory segment descriptors. Oh, this is great. These really nice diagrams, too. Yeah, Vince says they like the way it starts out talking about paging. Yeah, that's pretty good. Yeah, where do we get to later on? Oh, linking? Segment binding? Oh yeah, relative addressing? Entry sequences? Yeah, like this is like a stack of all the computer architecture bits. A lot of access control. Ooh, ring crossings. Sort of system calls, basically. I assume that's what they mean by ring crossings here. It's like how the system call arguments are encoded on the stack. I mean, I assumed that was a stack. I mean, it might just be some other chunk of memory. This is great. I'll have to go through this in some more detail. Wow, thank you. Oh, is that a library card in the back? Oh, yeah. Oh yeah, this is the library card. That's great. Yeah, well, thank you so much, Axel. I'll have to dig deeper into this and share some gems that I find with all of you. Well, thank you. All right, so to move right along in our whirlwind of a stream here, the next thing I wanted to get to is actually just to dig into the issue tracker and show some of the well, I finally started to try to organize the piles of notes that I've written on like stickies on my desk about what needs doing on this robot. And so now it's actually on GitHub where we can maybe start to talk about this. And I was realizing that some of the frustration in terms of, we would get into a discussion that felt like we've already been here, and it felt like, well, we've already talked about how this needs to be resolved. And that's why engineers use issue trackers, right? We can actually store this information in a form that people can refer to. Oh, I don't see the cat. Keep an eye out for him. All right. So, the GitHub presence of TucoFlyer right now is a separate organization. I haven't been doing it under, so like I've got my own GitHub at github.com/scanlime. That's where most of these projects that we do end up going. So a lot of the small stuff we've been working on goes here, like the Wiggler, and all the broadcasting setup that you're seeing right now is even in here. But TucoFlyer has its own organization because it's a collection of projects already. Most of the work lately has been this bot controller project, which is really the main software behind it. But there's also firmware, there's also layouts for the graphing that you're seeing over here. There's the mechanical design for the Winch bot and the flyer. Oh, was that? I think I'm just seeing things out of the corner of my eye. Where is that sunlight coming from? I don't see Took, but I'm just gonna park the camera here in case he hangs out on the rack again. I could get so distracted by driving the camera around. So yeah, lots of sub-projects here. It seemed to make sense to have a separate repository for tracking issues, since a lot of the issues would be across components here. So that's what I figured I would do. Got 18 issues in here so far. Oh, interesting. Vince says that book is still available for $74 on Amazon. Neat. Yeah, James suggests maybe an FAQ. Yeah, we could do an FAQ. Hasn't quite gotten to the point where I would know exactly what to put on it because things change so fast, but yeah, that would be a thing maybe. So yeah, this is kind of what's been on my mind as far as stuff to work on. There are a few things that would make it really easy to use kind of day to day as a recording robot. So that's under this daily usability milestone. Stuff like, if the gimbal isn't breaking itself and I can actually start and stop the recording easily, then I'd be able to get a lot more good footage with this bot. This is annoying. This is what kind of makes the bot like swing off to one side when it's powering on or when it's unhalting. So we could fix that. Event logging would be nice. Right now it logs metrics like this, but it isn't actually logging events. So for example, if there's a halt, I can't actually tell whether it was a manual halt or if there was an error or what kind of error. And I thought right now we would just start out with something small, since there's a lot in here. If you want to poke through here on GitHub. Some of these I've added some details to. If you have questions, I could try to answer them. If you have ideas, that's great. If you want to work on something and help, there are even a couple here that would be relatively self-contained, like the chatbot interface, if you want to work on that. There might be some other things like, I mean, obviously a lot of these things require physical access to the bot, but there might be other things that are more kind of about the web interface or about the overlay that we could collaborate on. But mostly this is here just to take like what I'm thinking and put it out here in a form so that you can kind of see what's in progress and what's upcoming, and where we can even talk about like, hey, maybe you should do a stream on this issue. We could talk about like what people are interested in seeing and what we could prioritize. So I assigned these two to me because I'm already working on them. I already ordered parts for a lighter leash, and I think this is next, fixing the LED signal integrity. So actually, I guess all that talk about parking the bot over there, I should bring it over here to the desk so we can work on it. Let's just aim the camera over here, maybe. Is this tense for anybody else? I think I can just put this right on my desk. Ooh, I'm about to hit the camera. Oh, I hit the camera a little bit. Oh, actually the microphone is in the way of that cable. I can't quite just lower it onto my actual desk area. I can get really close though. Halt. I'm sorry, I'm a little behind on chat. Let me see if I actually missed anything. James, were you talking about the controls here? Or yeah, I guess obviously where one stick moves around the center with the view pointing at the center. Yeah, that'd be interesting. Yeah, I mean, I think to be sure, I want a control coordinate system which is centered around the camera. And I think in combination with some feedback loop that tries to keep the camera at a set distance from the subject, that might end up working kind of similarly. I don't know if that's quite how I would implement it, but something like that maybe. Oh, the flyer analog sensors. Those aren't really giving us great data yet, but those are the collision avoidance sensors. Those are the infrared sensors that are all around the robot. And they're not quite aimed at the right place yet, and they're interfering a lot with each other, both of which are problems I plan on addressing with another 3D printed part that isn't designed yet. But that's what that data is. It's just not something we've really looked at yet. Oh, cool. Multicians. Yeah, those analog sensors are specifically just the 8 IR sensors. So they're all the same kind of sensor. They're just a ring of the same ones. The data you're seeing right now is weird for a bunch of reasons that I don't even think I really have time to get into today, but these sensors use this type of modulation, and the modulation is interfering with each other at this time scale, which is kind of interesting. Yeah, see these little runs of the same value and then a different value? There's actually like a sample hold circuit in each one of these IR sensors, and that's what you're seeing here. So we could go deeper into that, but I'm not going to right now. There are more hardware and software changes necessary before that data is actually useful. Okay, so let's show you the other problem that's preventing this from being really presentable, besides the wobbling, which is complicated enough that I don't want to get into it right now. Oh, where is it? Do I need to turn off these lights? That's not a bad view, at least. The gimbal doesn't like that angle. Okay. That was only so quiet because it was halted. Let me run it again. Yeah, you can hear the winches all respond if I touch it like that. And they'll actually end up raising it slightly as a response, but I'm going to halt it again. And with it halted, it's just going to keep this pointed at the same place. Okay, so the LEDs, can you even see that? Is that on the back side? Oh, it is on the back side from here. Yeah, see the problem? So that's supposed to be just a basic radial pulse, like a gradient traveling around. But there are a couple of distortions. So obviously there's that bright patch where there's maybe 1 or 2 LEDs turning on pretty much full blast for the part of the cycle. Then you can also see some flickering up here where that data is being inconsistently decoded. So it's almost like we've got Well, I mean, it could be something affecting like the first few bits of the packet where the brightness value is stored, which would be maybe a reason for the flickering to appear in the the overall brightness rather than a single color channel. But there are a bunch of reasons why this might be happening. I mean, we're using 3.3 volt logic to drive APA 102s, which is not guaranteed to work. So, assuming that's just what's going on, we could just stick a level shifter in here. It might be worth just probing around on the data lines with the O-scope just to make sure we can get a clear picture of what this looks like, though. And I think we've got time to dig into that. It would be nice to have this slightly lower on the desk, though. Maybe I'll try to maneuver this a little better. I'm always like, which button is down, which button is up, and it kind of matters. Okay, yeah, I've got to just dodge the microphone boom. There we go. Get a good view of the microscope. I like the window view. Yeah, I'm trying not to hit the microphone. Oh, how do you even camera angle with this bot? Oh yeah, there's also LEDs on top. They are subtly glitchy with that fade, so it might be hard to see on camera unless I dim the exposure, but that LED on the right gets a little bit glitchy as it fades down, probably for the same signal integrity reasons. I think the next step here is to trace out the wire and maybe free it from some zip ties. Maybe I want the bot further away from the camera. Easier to move the robot than the camera. So, so many questions from James every day. Do I have sunset views? Yeah, the sunsets here are great. They're hard to get on video, but yeah. And how often do I actually see the top of the bot? Well, every time I look down on it. Movement is looking fantastic. Yeah, I think there's definitely some room for improvement, but I'm pretty happy with where we're at right now with the level of tuning it's had. Okay, so LEDs. Which of these zip ties do I need to cut? I think the way I did this, the power goes right into the LEDs down here from the DC-DC converter, and then You know, actually, I think the best documentation of what order I actually wired this stuff in is in the source code. So let's check that. No, just that. Tuco flyer and then bot controller. The LED that's incorrectly flashing is like reflecting in the bezel of this monitor and then hitting me right in the face. It finds these ways to be annoying. It's really good at it. Anyway, this is the source code that maps where the LEDs are in the robots. Okay, so we're starting at the top, and then it's upper, middle, and then lower. Really? So that's interesting. That means that I was kind of expecting the LEDs that are kind of flashing full white, that those might be the first couple in the string or the last couple, but those are just in the middle. Is that actually right? There are a couple things that would be great to do to test this, like have a separate utility that just sends like a pattern with one LED lit and then steps that from one LED to the next. And I've written those before for this, I just don't have one in the current Rust framework. So we could either write one or just kill the Rust bot and use some Python code to send UDP packets directly to this. Aiden says to give the flyer a grabber for bolts. Yeah, a bolt grabber robot is definitely on the horizon. It probably won't be built into the flyer because it probably makes sense for that to be separate from the camera, because the flyer just needs to get a good view. There's probably another opportunity for a robot to be just like on the ground and interacting with Tuco. Got a robot emoji in the YouTube chat from PsyOps. Thanks. Well. So how did I wire this? The front of the robot is like inconvenient for me to get to right now. I can't rotate the robot, unfortunately. I think I do have to take this Kapton tape and maybe some of the zip ties off. So the tape and all that was partly for, partly to keep the video feed from going blank. Does that just need tightening? I think that cable just needs tightening. Okay, so the Kapton tape apparently was there to keep the video feed from going blank, but was also supposed to try to keep these wires from interfering with the IR sensors any more than they had to. It kind of helps. So we probably will have to put this back on or create the final shell for the robot. Oh, the shell should really be an enhancement in the issue tracker, since that's definitely planned. Oh yeah, and the bolt throwing mechanism should be in the issue tracker, yeah. Let's make an issue for the shell before we forget about that. So the flower shell is a cylindrical covering for the center of the flower to protect the wires and keep them out of the IR sensor paths. So that would go over this part. You can see I've kept the edges of the carbon fiber rods completely clear here to try to keep the center as skinny as it can be. So this could actually be a pretty thin cylinder that covers this. And so I'm imagining there could be kind of clip-on mounts for that, and then the actual shell could be made out of some kind of thin material like paper or plastic. Something like that. Labels, sensors, I think is a label I'm going to want, and enhancement. Yeah. I don't like having to have issue trackers for like everything, because it feels too much like real work, but they do actually help with organization. It was getting unwieldy. What? There's this, somebody's talking about throwing cats. That's a terrible idea. The whole point of this is to be safe for cats. I mean, a lot of this design was like trying to keep it from having enough power or tension to do a lot of harm. Giving it sensors so that it can detect if something is stuck or if somebody is stuck on it. Can I get this lower? I mean, I can get it lower if I just put it right here. That's too low. That's too bumping into the table. What is this trying to aim at? I think the PID is wound up again. Oh, I could refer to that by bug number now if I could remember the bug number. Oh, I could keep an eye on Tuco's bolt stash down here. Oh, the gimbal doesn't quite reach that happily. Keep an eye on the secret mouse. Alright. Okay. So these are the wires for the gimbal. Are these LED related? I've got to clip some of these zip ties next. Ryan says they'd like to see a cheetah chasing bolts, and Microsilent adds just get bigger bolts. That might work. This really doesn't want to be rotated. This bundle is just the sensor saucer. Where is the LEDs? Oh, it's back here. I think that is... Oh yeah, every time I rotate the body of the robot, you can see it. That changes the reference point that it's using for the drift compensation stabilizer. I think that was too many words. The drift stabilizer or drift compensator would have been enough. That sounded like a Star Trek object. Yeah, great idea. I think I ran the LED wiring like right next to the power input. I'd been meaning to redo the power anyway for the lighter leash. That involves 24-volt power and less copper. Oh, what's that? Just pulled on the robot and it went somewhat lower, but I think it's just springy right here. It's pretty springy when I'm not trying to twist it. Okay, I think this is... Oh, what is this? There's like an input and an output for the LEDs on the top of the flyer. I think that's the output plus the power. And this would be the data input. Oh, why did I use this connector? Oh, because I think it was out of the others. Okay. And I think the video's loose again. Adrian's asking about the XT60 connector. Yeah, it's really overkill, but it was mechanically pretty sturdy. I'll probably have that connected to some 28 gauge wire for the next leash, and you can all laugh at me. Oh man, I might need to re-terminate this coax. What is going on in there? I think the pin in this BNC just is not making contact. Unless the whole thing is kind of wiggling to the side. Well, I don't know if it's the BNC or the BNC to SMA adapter here. One of those. Anyway, will that also need to end up on the issue tracker? Anyway, here's the LED data. Oh, I guess this was just because I wanted a 3-pin connector. Specifically, I didn't want this to be compatible with the 4-pin, so I used like a servo style lead. Fine. I'm just gonna stab my scope probe in here and try to find the problem. It's like my thought is we should be able to see like a good waveform and then a bad waveform and then something in between. And it might just be the waveform starts out all right at 3.3 volts, and then the first time we pass it through to the 5 volt domain, it's terrible, which is fine. We could just add the level shifter. I just want to make sure that we know what's going on. Oh, hunting for grounds. Oh, I added plenty of grounds to this microcontroller board at least. Knee cam. The best in gimbal stabilized knees. What do we got? To make this easier to probe, I might splice another servo lead in the middle here. Oh look, here's one on my desk. I'm just going to take this and tear it apart with my fingernails like a monkey. Monkeys do that to servo leads, right? I saw it on National Geographic. Or was that scanlime? I don't know. And then I think instead of trying to do something fancy, I'm just going to cut these and twist them back together. But in kind of a staggered pattern so that the twists don't all sit at the same spot. The scanlime, wild beast, stalks its wily assembly language opcodes. Yeah, for the thinner leash situation, I also got these Meanwell. Well, I got a couple because I like to have a backup, but I got this Meanwell 24 volt, 25 watt power supply that seems like a good fit. This should be about twice as much as the power that it usually draws, but not so much larger that if I have a short circuit or something, that it'll just make a great heater without throwing any faults. Am I gonna hot plug these LEDs? I don't really want to hot plug the LEDs. I'm gonna briefly power off the bot to plug the LEDs in. Which means I'm gonna power off the gimbal motor and the bot. It would probably be safe to hot plug these. I just didn't really want to take that chance. Alright, that's plugged. We should start to get video. Yeah. Okay, now just to investigate what this is looking like at the very beginning of the signal. So that's data. Let's take a look at clock first, just to make sure there are no surprises. So at this time scale, we can see individual frames. They're not spaced extremely accurately because these are all coming out from like user mode software on a PC. So it's somewhat regular but not great, which is fine. And then we look a little closer. Let me just set the hold off. Oh, why am I not catching just the beginning? I mean, I do at this time scale, but I was trying to use the hold off to have that same effect when zoomed in. Anyway, that looks fine. We just have a bunch of bytes going out. Bytes. Alright, let's look at the data. So what we're seeing in reality, which is wrong, is the kind of flashing single LED. What we should see in the packets, if this is right, is not that, but just the smooth gradients. That's better. This also has a few different regions. Yeah, so you might be able to see a block of 4 groups of LEDs at the top. Those are the 4 strips on top of here, which are each in, like each strip is fading as a unit. Yeah, this section. And an individual LED looks like that. And so there's some space over on the right side that we're not using, it looks like. Not sure why that's there. I think we're just sending out a fixed size buffer, actually. I think that's just like a big pound define. I forget. Oh, no, actually, no, the buffer is dynamically sized. Those are the extra clock cycles you need to stick at the end for the APA 102s to finish clocking out the frame. And then these are the 3 LED rings, which look like they're the same data. I think they should be the same. Looks pretty normal. And 3.3 volt logic, of course. All right, let's see how this looks after going through some amount of the LED data chain. So maybe what I'll do is poke a second scope probe into the data line after. So the first LEDs in the chain are the ones at the top, those first 4 groups. So I'm going to poke a probe in after that point, and we should be able to watch the rest of it come through after the first group of the pack, or the first section of the packet's been slurped off. Ignoring clock, since it's pretty regularly spaced, and we can just guess that from looking at the scope. But yes, there is a clock signal also, because these are APA 102s, not WS2811s. Just another random ground on the circuit board. That's not so great. I guess it'll work. Yeah. I'm gonna grab a ground from a header stuck into the back of this circuit board. Oh. Let's go back to this view, I think is what you want. So that's the clock. It seems okay. Not the cleanest signal, but I don't see a terribleness to it. Well, that's a ground noise. But I do have a pretty bad ground at the moment on my scope. It's like far away from the LEDs. So for the first section of this packet corresponding to the sequence of LED strip that I'm probing the output of, so that's all zeros. So until they've consumed the preamble for the packet and all of their individual bits of LED RGB data, the output's all 0. And then when we get to the end of that segment of the LED strip, we start picking up the individual input bits. And I expect to see that on a bit of a delay. Yeah. I think the delay is something like a half a clock cycle per pixel. So far the wave looks bad, but I don't see anything that's like definitely being, I mean like it looks like all the bits are being interpreted so far. The waveform is just not clean. And so maybe way down the line this causes the bits to start being interpreted incorrectly. Oh, never mind, that's already a problem. Huh. Has it decided that the frame is already over by that point? That looks a lot like a smoking gun to me. I mean, maybe we're not quite at the root cause, but this is definitely a problem. And that corresponds with the light pattern that we're getting from the LEDs after this part in the chain. Oh, sorry, I'm a little behind in the chat. Oh yeah, VJ, nice to see you. I'm glad you caught the stream live. It's nice when folks are able to do that. It's the time zones are kind of tyrannical sometimes. Oh, I was like, I'm gonna be very gentle with my robot. Elbow smack. So that creates like a hole in. Oh. That creates a hole of the same length. I wonder if these packets are actually, if the LEDs on the top of the flyer are actually starting a different frame and they've like eaten a second frame's worth of data. That might explain why there's that really subtle flickering. Like maybe, this might be a software bug actually. This might just be we're framing the data incorrectly, and so maybe some of the early LEDs in the chain are interpreting our single packet as multiple packets, or like our single frame as multiple frames rather. Oh, and Sean says hi from the land of Oz again. Nice to see you. That's the same length. And so what's... Oh. Oh, is that a smoking gun even? So if we find the point at which that green trace disappears, there's a little gap in the upper trace too, like maybe a single LED that's missing its prefix bit. That would do it. That is definitely a software bug, which is causing this, and not a hardware bug. Cool. So we might not even have to modify anything. That LED, so right under where that orange cursor is on the top of the screen, I guess it looks kind of yellow on that screen, But yeah, there should be a blip there to be like a start bit for that LED, and it's missing, which means that those LEDs are going to start a new frame, and we're going to get some Mondo flickering weirdness like we've got right now. Pardon the flickery trace here. But yeah, okay. Let's see if we can find that in the software. Maybe even add some like asserts or something so that we catch that before we send out such a bad packet. And before you're like, all right, Micah, time to go to the firmware. I'm like, no, actually, it's not in the firmware because I decided to do all that on the Rust side. The firmware assembles the header and the footer for the whole packet, but the Rust code is actually responsible for the header on each individual LED. And the firmware does not verify it. So we're headed to the Rust code. Am I still gonna have, these wires are all hanging out, and let's take out that first O-scope probe at least. And then head over to software land. I don't have that much more time left in the current stream, but maybe we can at least find the bug, because maybe it's actually really simple. Maybe there's like a not a number or something that's turning into a blank LED. That's the kind of bug I feel like I would have in this code. Okay, so there's just going to be this horrible mess of cables now. I'm going to drive this somewhere slightly more out of the way. Oh. Whoa, hi. Oh, that's... Oh. The roll on the gimbal just keeps getting worse. What's going on? Let's restart the gimbal. I think starting the gimbal in such a weird orientation was not a good idea. Huh. Let's try power cycling the gimbal when it's more flat. I think that might help. That is something else to go on the bug list, is I think maybe the gimbal is having trouble starting up when it's in a weird orientation. And that's something else we could probably fix in software. Oops. That was my elbow. Okay, I'm going to try to give this some help starting up. Oh, it is still in a very roll sort of mode. Oh, and the roll is just drifting. Yeah, this is a problem. That is severe. Oh, it's settling out when I turn this direction. Oh, and then unsettling. Gimbal. Oh man, gimbal. I don't know about this. again, I don't know why the gimbal roll issue is so much worse sometimes than others, which I think underscores just how little I understand of what's actually going on behind this problem. To the tracker, yes. What is it trying to do? Oh, man. I try to move the gimbal and the robot moves a little bit sometimes because the joysticks are not zeroed. Alright, this is usually the auxiliary display for the robot. But we can also use this as a computer for editing the source code. Just listening to the gimbal, can you hear that? It's not that loud, but it makes strange noises. Alright, bot source code. LEDs. So it looked like that blank LED was happening between these two parts of the model. Am I going to regret trying to print this at all? Almost certainly. I probably... Is it easier just to use like TCP dump or something to get this? I wonder if we could just look at this in Wireshark. All the log messages. Yeah, there's another issue in the issue tracker related to having another logging facility, which might be useful for this too. We could take a detour, but I don't have time for that in this stream. I don't know if this is Ethernet or Ethernet 2. I'm gonna make a guess that it's Ethernet 2, and that looks right. This is the bot traffic. That should be plenty. I don't really remember how to use this tool. Okay, these are just the UDP packets going to the flyer. So packet 1, what is that? That's a gimbal packet. And 5 is LEDs. So pretty much all this is gimbal and LEDs. I think that's the only outgoing packets we should have, actually. so we've got LED data. Can I sort these to only show me the LED data packets? I mean, I could check it out by length. What would IP think the length is? 573? Yeah, LED packets. Now I can watch the fades. So this is the same thing we were looking at on the oscilloscope, but before the microcontroller gets its hands on it. So you can see the sort of fade move down the packet as we go. And I'm expecting to see a point where the little E header disappears. And so this first section, yes, we have these 4 separate groups of LEDs. It might be easier to count the LEDs at this point, actually. So 5 is the packet header, and then each LED is one of these 4-byte regions. We have 5 per side. So that's not very big. Yeah, so this section, this 10 thing is the end of it. E 10 10 10. Huh. Yeah, maybe the problem isn't actually in the data, and it's just the this particular pattern causes the levels to go and not quite hit the threshold. But that looked like it was just a solidly single pixel that was missing from the oscope. I mean, yeah, we had the oscope on the data coming out of the microcontroller. So if the problem isn't in this packet, then it is in the firmware. Let's just do another trace. Maybe I missed it. Yeah, that's definitely got it by now. Seems like the problem should be right around in there, but I don't see it. This may be more subtle than I thought. I thought we had an easy smoking gun right there. Oh, a drive-by wave from Mark. Hey, nice to see you. Yeah, so I point to you what I'm seeing here. So there's this block of LEDs that have 5 LEDs of the same value, I guess 6. 7, okay. If I stood up, I could see. Yes, it's 7. So that's 7 of this 5, 18, 18, 18. So that ends right here, and this E2 is the first byte of, like, this is that location that I think we found on the scope where there was just like a 0, 0, 0, 0, 0, like missing word in the scope. And this looks fine, it's E2 888. If we keep going and looking at that location, it's funny, my monitor just went blank right there. So like it's just doing normal stuff. E1 through E5. Those are just brightness levels. That E, which is the important part, stays there. So yeah, maybe something more subtle is going on here. I'm going to have to wrap up this stream for today, but this does leave us with an interesting mystery to dig into, and if you folks have ideas, then be sure to leave them in the Gitter chat, or on the YouTube comments, or in the bug tracker, and maybe you and I can get to the bottom of this together. In the meantime, we've got a somewhat working robot here to poke at, so that's pretty fun. Well, thanks so much for dropping by, anyone who spent some time hanging out here. And special thanks to everyone who supports the channel by sending us hardware or books, in this case, thank you. Or by, tossing a couple bucks my way on Patreon to help me pay shop rent and keep Tuco fed in comfort. And so, yeah, this is all thanks to your generosity. And I'll try to do my part and keep it going by providing interesting live streams and edited videos for all of you to hang out with. Let's kill the power to this gimbal before the roll drives me crazy. Alright. Happy hacking, folks. I'll see you next time. I would have a much better time ending the stream if the keyboard focus was in the right window. Yeah, and try to keep the human fed. That is on the agenda. That is one of the reasons I'm ending the stream now. See you later, folks.